I wanted to have a quick poll on how many of you here, we have a huge number of audience today, and how many of you are actually having a problem with delayed deliveries? Can we have the poll up, please? I would request you all to vote on the screen. All right, so looks like 84% of the people in the call today have a problem with delayed deliveries in their business. So this shows that it's a very significant problem when it comes to the industry. And what's the solution to fixing delayed deliveries? And where does it begin, right? And that is where the concept of arrival time or estimated time of arrival, or ETA, as it's often referred to, comes into place. And today we have, we are going to talk about essentially five topics, right? We are going to begin with the business problem, which is delayed deliveries. And then we are going to dive into what current systems do and cannot do when it comes to predicting arrival times, because delayed deliveries is essentially a result of not having your arrival time calculated accurately. The third section we're going to talk about is the Romby way of ETA. How Romby has figured a way to make ETA for commercial shipments more accurate than most systems available in the market today. We will end the webinar with a little bit of details about Romby, how Romby approaches IoT, business-wise and monetarily, as well as the service model. And we will close out with questions from you. There are a lot of questions which have come up front to us. We will address them. At the same time, I encourage everybody to also ask your questions, or feel free to talk to us at any time during the webinar. We will be noting down your queries and we will try to answer 100% of them. Can we move to the next slide very quickly, please? All right, so before we move to kicking off the first part of this webinar, I wanted to talk a little bit about our host, Sailesh. Sailesh, welcome to the webinar.
Thanks, Prem.
So Sailesh Mangal is our Vice President of Engineering. He has a large number of years of experience in this field, building enterprise and web applications, and enterprise and web applications in a manner such that it's very agile and nimble, and in environments which are fast-paced, like the Internet of Things. So Sailesh holds a master's in IT from the University of Texas and a bachelor's in engineering from MNIT India. But that's not all. Our host Sailesh has a few interesting facts and a life background which kind of inspired him to work on some of these innovative projects where he's stretching the envelope with Romby and the field in general. So Sailesh, Sailesh, if I was to say, at a very young age, since I know him, he had a broken arm, and instead of taking time off in his school, he actually practiced writing with his left arm, which kind of probably is the reason why there is a lot of artistic thought process in the engineering that he is doing with something like the ETA concept. He's also Sailesh is also happened to not be able to know the difference between a robot and a computer at the age of 12. Probably another reason why he became so passionate in this field of computers and IT. So Over to you, Sailesh. We would love to see what you have to talk about in your whole endeavor of making ETA accurate.
Thanks, Prem, and thanks for this wonderful introduction. I just remind our listeners that that was age 12. Things have changed quite a bit since.
Thank you, Sailesh. So, Sailesh, would you like to talk to us a little bit about how delayed deliveries impact businesses? When we talk about impact, we're obviously looking at a monetary impact when it comes to businesses as well as customer satisfaction. So if you could touch upon that and take this off, we would love it.
Absolutely. And to begin our talk around this, let me start sharing some of the stories that we have heard from our own customers and then the industry in general. The art of ETA, or knowing how and when your shipments will get delivered, is a crucial component in your supply chain. One of our largest manufacturers of tires in India, they care about it because this helps them avoid any kind of idle times or any surprises in their manufacturing. Another very big liquor manufacturer uses this to avoid any kind of penalties that they will incur ultimately to their suppliers and transporters. This helps one of our FMCG companies to make sure that they don't have to pile up high amounts of inventory at their manufacturing sites, both in raw material as well as in finished goods. And lastly, we are all familiar with typically having to wait at our home when we are expecting some deliveries. You'll get an email from FedEx or UPS or wherever, and your delivery windows are as big as a whole day. And then you'll either have to work from home or make some arrangements if you are expecting some high value packets. The story is not very different, basically, for one of our other prospective customers, where they are actually trying to solve this problem by bringing down the delivery windows to, let's say, 15 minutes, where you can be as predictive as a 15 to 20-minute window to get a package delivered. All of these companies have taken steps to make sure that they know the delays involved in the deliveries and to avoid them ahead of time, take corrective actions as things happen. The impact of not knowing ETA or not being able to do anything about it, and especially as we move into logistics 4.0, where we call that we are technology savvy and we have all kinds of sensor data, is not benefiting if we can't put the data to action. The impact that we see is in the form of delays that happen, which has tangible and intangible impact on business. One, that it impacts the business image directly in the outer world, but internally also it makes it difficult for businesses to carry on the plans that they've made. They have to remobilize the resources. There's a wastage of manpower. The plants have to be shut down, or you have to pile up high amounts of inventory. Ultimately, all of these things impact the brand image, the overall execution of the company. So not having this level of intelligence impacts both the inbound or inward operation of a business, as well as the financial implications in the overall business execution. Let's take a look at some of these numbers. And this is very conservative estimates, basically, that we've collected. But companies as big as UPS have only been able to achieve 85 to 90% of deliveries on time. And rest, they have to rely upon these kinds of systems to tell them what is getting delayed, right? In other scenarios, the delays involved, the inherent delays that we have in supply chain, and that get exacerbated by other impacts, such as weather conditions, such as issues that happen in real world are directly impacting these businesses. So what do we do? And what is the mechanism through which we can avoid these kinds of unforeseen or unknown delays, right? So how do we put a full stop to all of this? Well, this can be tackled by us knowing accurate and an actionable ETA or estimated time. And this is not just a matter of knowing this ETA, how accurate this ETA is. What is the factors that have gone in to figure out the accuracy of this ETA? Is it really tailored to a particular business need, or is it just a generic ETA that everybody is looking at? And how a business should really evaluate the different options that are available in the market and put this ETA to use to be able to overcome the inefficiencies that are inherent in the supply chain processes, to get rid of any kind of idle time that they have to incur, to be on top of their execution plans and achieve the targets that they have identified and have accounted for in the beginning of every year, and avoid unforeseen delays, either due to any connections that you miss out on because of the delays that happen in the road travel, connections that you miss if you have any air freight going on, or any ocean journeys that you might have.
Sailesh, that's very interesting. So what you're essentially saying is that more than relying on your enterprise software and tools like the regular maps that you have, there is much more to predicting ETA accurately. Is that what you're trying to say? I mean, or are you trying to say that in a commercial shipment scenario, the tools that exist in the market today are not reliable? Just wanted to understand that a little more before we move forward, because you're talking about accurate ETA prediction here.
That's correct. And that's a very, very good insight, Prem. So what happens today in market is we have certain tools available at our discretion. And these tools can be used by companies, some companies that are savvy or trying to be on top of these kinds of deficiencies have employed certain solutions. So let's first take a look at what these solutions are in general.
Okay, that's awesome.
So to start with, the most common method to get the ETA prediction is essentially have some device that gives you your current location of GPS. And in lack of that, many companies even resort to using driver's smartphone for tracking the vehicle. Then you combine this with any kind of mapping technology, which may have an integration built with some crowdsourced data. We have known Google has done it for a while. Mapbox has, TomTom has some crowdsourced data, which will give you a certain type of ETA. Now, if you drill into this ETA, essentially what this is doing is it takes the highway speed into account. It looks at the traffic that you see, and it takes the location of the phone, and it'll give you some estimate of the ETA prediction. Now, when you think about it, this method looks pretty standard. It's like everybody uses this. As consumers, we all use it on day-to-day basis. When we go from home to office, that's typically what you do. Or if you're in a new city, this is the main mechanism that you would use. What's wrong in this when we consider the same mechanism for businesses? Let's take a look at what are the issues that are involved. Well, first of all, this method essentially relies upon a device. Let's say in cases where you use a phone is not a very reliable mechanism for businesses to trust upon. Let's say a phone runs out of battery, you will have no idea, and your entire ETA will be stopped in the middle. Or if the phone is not being able to connect to internet, it becomes difficult. Other issue that comes in is that it somebody has to sit down and look at it constantly, or you'll have to perform some integrations to see this data live. It works well in the last mile delivery in urban areas, but if you are not, your shipments typically span across multiple cities. Most often it's even multiple countries. And in that case, this mechanism doesn't fare well. This style is built essentially for consumers, which are typically using this within the cities, within the urban areas. It is not really accounting for many other issues that happen within the cities, or as we change the mode of transportations, the delays that we see at the border exchange, for example, or at the port, that delays that naturally happen. There is no way for it to take into account. Pretty much any delay that happens other than traffic, there is no way you can customize these things for. And finally, if you look at all these considerations that businesses today have to put in, the consumer-centric ETA is actually not a very good way for businesses to start. And hence, the accuracy of these ETA predictions is actually fairly basic and not very useful for the businesses. And finally, if you have, and most businesses do today, certain limitations or certain conditions that are being imposed for transporter, there is no way you can have those limitations being shown in the ETA predictions that we have.
This is very, very, very interesting, Sailesh. So essentially what you're saying is that the ETA that we use when we send our friends our location, when we are traveling on a cab, for instance, or when we tell our friends, when you tell your friend in LA that you will reach in 3 hours, you might reach in 3 hours or 3 hours 10 minutes, or maybe 3 hours 50 minutes, if the interstate highway is pretty free. Right? But what you're essentially saying is the same does not apply to trucks. The same does not apply to consignments that move across multiple modes like trucks, ship, and air, like in the FedEx example that you were showing. And what you're saying is that it does not account for your use case, which means that if the trucks have scheduled stops, it is not accounted for. Is that kind of what you're saying when it comes to the fact that consumer ETA does not work for businesses?
That is correct. And those are some of the good points that you have just counted here, Prem. There is a lot many more that we will be covering in today's discussion. And we'll go into how Rombi has taken a stab at this problem, how our journey started in this. At this point, I actually want to take a quick pause and urge our listeners to think about where you are in your journey of ETA. How well do you think you are informed? How much of a problem it is that you know of today? Are your tools that you use adequate to achieve the results that you expect them to achieve? And in the next section, we will cover our journey through this process, how we started, how our ETA predictions have changed over time, and how what we as a company receive a lot of feedback from our customers, and how that has gone in and changed the way we look at ETAs today.
Wonderful, Sailesh. So that actually gives us an idea to have a poll. Maybe how about we ask all our respected viewers how their current ETA system is faring for them. Team, can we have a quick poll up on the screen? Thank you. Would request your responses. How satisfied are you with your current ETA system?
Yeah, and many of you may be at different stages in your journey towards getting up to speed with this level of information about your own supply chain, your logistics, and based on that, I think it will help you to understand what a true ETA system can actually bring. And at this point, if you can just take a moment to think a little, find, and share with us where you are in your journey of being informed about your supply chain, and how live that information is, how accurate do you find that information? Is it actually helping you to alleviate some of these problems that it brings? Or is it more of a check-off item that you have on your screen? So
Yes.
we
So
have the
Sailesh, we have
results.
some poll results, and from what I see, we have people in our audience from multiple industries. FMCG, pharma, automotive, and very interesting. The poll says that only 5% have voted yes. Um, the majority say they are neither satisfied nor dissatisfied. This is interesting because a lot of times, I'm assuming from what you said, there is some form of ETA, but we are not sure whether it's the right ETA or not. Then we have 27% followed by that who say they are satisfied, and then we have the rest who are dissatisfied, or wait, actually 20% here do not have an ETA system. Very interesting combination, Sailesh, I think, which validates the point which you say, that either there are no ETA systems in place in a lot of logistics operations today across the world, or there are ETA systems which are there, which are not faring well, or there are ETA systems which are there, but the value of that system and the accuracy is in question. Um, this really excites me. I want to start hearing about what you have in store for us. There is some artwork you have done with ETA from our previous conversation, and I think it would be awesome for you to maybe talk a little bit about that in context of the audience opinion.
Certainly, Prem. And these results are very much in line with what we have been hearing from our customers. In most cases, every company has started the effort in some shape or form, but they are not getting the results that they were expecting to get, or the system is actually not working the way they wanted it to, right? So what happens is that these kinds of initiatives then turn into a check-off items somewhere in somebody's spreadsheet, and really don't bring the day-to-day advantages that they were originally conceived to bring. So let
That's
me
very interesting.
start with what is ETA in Rombi's terminology, or what we sort of take. What is our take on ETA? So the journey that when we started did not start exactly this manner where we are today. And like many things at Rombi, we learned from our failures, from our mistakes, and we perfected them over time. So to start with, we rolled out our first ETA a couple of years ago. Now we call it Basic ETA. Essentially, it was very similar to what consumer ETA is. We accounted for highway speeds. We got traffic delays in the picture. The only thing that we had extra was that because of our devices, we were getting live data, and we were providing the live course correction to these ETA numbers, and making this ETA available in the form of some alert, or some display and SMS and email to the end users. This became popular because it's readily available. It was right there on our UIs, and it did basically what it was supposed to do. But very soon we realized that it ran into the same problems that we discussed earlier with consumer ETAs. It didn't fare well over the long distances, right? It didn't take into account anything around speeds, or the driving times, or what is the stop behavior, and any other historical data that we had collected over the years. we were not using to make it better with that. So very quickly, we realized that it is a good start, but not something that businesses entirely can benefit from. So that paved us the path for us to move into our next level of innovation. And that was around bringing certain aspects of business into our ETAs, how we can make it better by listening to the different specificities that individual businesses bring to bear, and use those to make modifications and make it better for individual customers or accounts.
So, Sailesh, if I was to interject and ask you something, when you talk about basic ETA, you also said that it actually worked for customers. So when you say it worked, are you talking about the fact that they were able to collect data in a very easy manner using our portable tracking devices or our Rombi app? Is that what you're kind of referring to when you said that it did work, but it had its drawbacks?
Right. So it did work in certain conditions, wherever we had shorter shipments, very predictable routes. Let's say any shipment that is less than 6 hours, a very defined route, nothing changes much. There are hardly any surprises in those journeys. Or if somebody is only looking at local deliveries, in those kinds of scenarios, it fared well, right? And that's true with our consumer apps as well. I mean, if you take your example, basically going from San Francisco to LA, that's a pretty straightforward journey. I mean, you can take simple Google ETA or any other ETA for that matter, and you will pretty much stay the course, and nothing in terms of surprises you'll run into, right? Things change when you have large businesses, right? It changes when you have long distances to cover. It changes when you have shipment going over land and then in air and then ocean and back on land and then train. When you combine these things, it becomes quite different.
Got it. Actually, Sailesh, there is an audience question that came in, a very interesting one while you were explaining this aspect. So the question goes, what is the classic long distance? When you say long distance, is it 100 kilometers, 200 kilometers, 500 miles?
Right.
What's that?
So the boundary of long distance, the way we treat, especially when it comes to ETA, is that if it warrants for a stop in between, and if you look at any sort of human motion study, you will realize that there is a designated wait or rest area every 4 to 6 hours that user will take. So any shipment that exceeds that limit basically will we will term it as long distance for us or for our ETA calculation purposes.
Wonderful. So I look forward to see what the next evolution was.
All right. So building on our learnings of basic ETA, we extended it further, and then came basically 2017, which is where we added additional customizability into this ETA. At this point, we started listening from our customers if they have any guidance around what is the speed that they want to set forth for their transporters, if they have any limitation that they want to impose on number of hours that are allowed for a particular truck or a driver in a day, and also look at all the historical data and analyze where typically on a given route trucks make a stop, how long do they stop, and use these factors to customize the ETA and take it further from just the basic aspects to Rombi ETA or customizable ETA. This also becomes interesting where in certain countries we are starting to see that there are new rules that are coming into picture. For example, in the United States, the increasing adoption of ELD, or in fact now it's a law that every transporter has to enforce, that the number of hours that a particular truck or a driver can go is limited by the law, right? And they have to produce the entire log of that. So given these kinds of limitations that impact now the ETA predictions, we have a system that these things can play a role, and we can work in compliant with existing ELD solutions and provide ways to enforce and reflect these numbers in our ETA. And essentially, the way it works is we take the basic ETA every leg of the journey, and in that leg we analyze with the allowed speed or not. We combine the allowed hours for the day, and if a journey is essentially over few days, these numbers actually play a bigger role than a simple traffic or highway speed. And that basically brings us to the customizable ETA, right?
Lovely, Sailesh. Now I understand what you mean when you say customizable ETA, and you're talking about the ELD compliance, where things like transport safety on the road, uh, the restricted time movement, and respecting the speed limits on the road, not only is a safety initiative, but it's something that can drive business efficiencies when you put that into your ETA prediction engine. Is that correct?
That is very true. That is very
So
true.
even if somebody has a ELD, they can still get their ETA by using our system, and not only adhere to compliance, but also ensure that their shipment is delivered on time. That's what I'm kind of understanding from this section when you talked about ELD.
Right. In fact, our solution complements the ELD systems very, very well.
Mm-hmm.
While ELD mandates the number of hours usage and require companies to produce a log file, electronic log, to prove that, our system actually can take and work with those limitations and reflect them into our ETA predictions.
Wow, that's very interesting.
So the journey for us did not stop there, right? We looked at the system. The system was better than the basic ETA in many by many folds. But what we started realizing is that um, if there are one-off cases, let's say a vehicle broke down, right? Out of the 100 journeys, one journey the vehicle broke down, and that journey basically will skew the ETA for the subsequent journeys in further. So we start realizing that the data that we collect, the magnanimity of it, the size of it, was overwhelming for any individual system to take into account and produce meaningful results with. And that brought us to the next step in our journey. And that turned out to be a technological advancement by many folds. And that's what we call predictive ETA. Um,
Interesting,
so
Sailesh. So when you say predictive ETA, are you talking about things like machine learning? Is that what you're getting into? Okay, I see that on your
that's
slide.
right.
Wow.
That's right.
I think you answered that.
That's right, Prem. So the technological advancement that we witnessed helped us to crunch all the data that we have collected over the years about different routes, about different transporters, about different accounts. And we analyzed and we studied, and we were able to set up a pattern where now, as humans, we don't have to sit and build these algorithms ourselves. What we have done is we have created these models which, based on these machine learning algorithms, they can crunch data in real time and apply these one-off conditions, or make sure that they don't skew our numbers when we have one-off exceptions. They don't become the norm. Or if something does become a norm, it automatically gets reflected in our ETA. So what we started doing earlier part of this year is to analyze every repeatable routes that we have. And we then created what we call in the data science term supervised learning models. And we did it per route. So we have specific routes for which we have created these models. These models are extremely highly accurate because they have the capability of going back in history and analyze all the trend and apply that learning automatically to all future journeys. And that's just not it. It's an iterative process. So as we collect more and more data over time, it improves our numbers as we generate them. We are currently supporting all repeatable routes that we have. And the definition for repeatable routes is basically it has to have shipment data in our system for X number of times. But using this intelligence, we can even get started on any new route today. And then as we gather more data on that particular route, we will improve this mechanism.
So that's an interesting point that you make, Shailesh, because if I was to look at it as a user, are you telling me that you would advise me to run this solution on a particular lane for a few weeks or a few months, and what would that period be? And also, can I get samples on multiple lanes? It would be nice if you can elaborate on that, because it finally leads to how we can adopt the system most effectively and in the most cost-effective manner without investing much upfront, right?
That's right. That's right. So, and that's a very important, I think, aspect of this system, that the technology of machine learning and data science, there is enough knowledge that we have gathered and the data that we've collected that we can pretty much get started on any route, right? And the beauty of the system is that as we collect more and more data, system will get better. So in scenarios where we have to start from a new route, we will basically take one of our generic models that we have trained for generic conditions. And as we gather more data on that particular route about who the transporter is, and there are many other features that actually goes into this. Let's take a look at some of these features that help us shape our mathematical models to do a better prediction. This includes the dwell times that we see, corrections that are specific to geographies, temporal collections that essentially mean that what is a typical start delay, right? So from when customer says that my shipment will start at time X to when it actually starts, is there a pattern in the startup delays? What time of the day shipment starts, and does it have any bearing on the overall ETA? So these kinds of trends that are not directly correlated with the ETA, but have some derived correlations which are difficult for humans to harness, can easily be harnessed by machine. And that's where I think this beauty of these models come into picture, that they can apply these kinds of corrections. They can keep ETA much more accurate based on the field conditions as they observe over time.
Very interesting. Do we have any data to kind of compare how we were doing when we had the basic ETA versus customizable ETA and predictive ETA? Any slides on that you have planned, Sailesh? Because after you've said all of this, I think I think it's very exciting to see how this is probably worked out for some customers, or maybe some kind of a case study for a particular client. Is there something that you have in mind or anything ready to share?
Yes, yes. Let me quickly talk about how this system works. So don't go to the depth of the slide. Basically, there's a lot of different systems that come together to
Sure.
power the data and crunch this data. But essentially, in a nutshell, as we collect this data goes through our pipeline. And from this pipeline, we feed this into our analytics. And is that where the analytics actually goes through the set of algorithm, and at each stage we enrich the data. We figure out if this is a point that we should consider, or is it a one-off exception, and all of this data then get fed into our pre-learned machine learning algorithms and learned from this data. At any point of time, this intelligence is made available through our APIs, and we can see that based on where the shipment is at any given point of time, and all the other aspects of this, who's the transporter, what route it is on, what day it started, what time it started, we can actually provide this ETA as simple as a simple REST API call. You talked about comparison data. This is a real world example that we took from the live data that we have. We analyzed about 30 odd routes for their basic ETA prediction with the predictive ETA predictions. And the basic ETA is shown in red, and the predictive is in the green. And the y-axis, we are showing the level of error that we see. And very quickly, you can reach the conclusion, basically, that the predictive ETA is anywhere from 2 to 2.5 times better than the basic ETA, right?
Wow,
And
so you actually field tested this when you say this. This is very interesting. And how many months worth of data was this? Just out of curiosity.
right. So we took all the data that we had on these routes in past, and the way if you look at any data science project, basically we divvy up the data into training and test data, and that's where these models got trained on, and we repeat that exercise every few months, and retrained models get released in our production. This system is available for people to use right now. Our customers are benefiting from this right away as we speak.
Thank you, Sailesh. We actually have a couple of questions from the audience here. So one is if you can go back to your previous slide. Uh, I would request 2 slides before. You were talking about geo corrections. What are they? Are they correction of GPS locates?
No, essentially this talks about the specific delays or a specific changes that ETA requires based on certain geography that we are in. So there are specific conditions that could be true in let's say Southern Asia, but may not be accurate in Europe. So those are the geo corrections that system actually take into account and provide. So if you do an ETA in let's say Malaysia, will be different from the ETA in the United States.
Got it. So there is actually one more question that came my way here. Actually, a couple of questions. This is back on your comparison slide, which you had showed us. Is the comparison a percentage comparison, or is it a transit time in hours comparison when you compare these trips reviewed? So when you say 20 and 40, what is that? Hours, minutes, percentage?
It's actually a term that we use in data science called RMSE. It's a square mean root error that we generate that from the actual ETA or actual arrival time, how far the basic ETA was and the predictive ETA was. So it's a percentage error. It's actually more complex, but think of it for now that how far you were from the actual number.
Got it. But the reduction is very significant. It's almost like you say, 2.5 times, right? In the comparison of the basic to the predictive.
That's
wonderful,
right.
Wonderful. All right. So Sailesh, it would be nice if you can talk a little bit about the usage model of Rombi, because when we talk about ETA and predictions and all of that, there are essentially 2 main aspects that come into play, right? Which is collecting data, and collecting data in environments where it's been previously close to impossible to collect, say instances like multimodal shipments. The second is, of course, analyzing and making sense of the data, which you talked extensively about. So how can our audience kind of get a taste of this without investing very heavily, because this is something that you are constantly improving, and you said that the system gets better with time. So there should be some place where you can start small and scale up. Is that something you could talk about in terms of the business model and how Rombi approaches that when it comes to giving a taste of this to our customers?
Absolutely. So even before I get into how Rombi does it, my first advice to everybody is to, if you don't have it already, having something in place, knowing is better than not knowing. And those who actually know should think about how we can get better, can get more accurate. Talking about Rombi solution, I think we have been a very firm believer of getting technology in the hands of people with as little as possible or with almost no upfront cost. So one way to get started is essentially start with the mobile device. Those are very, very easily, readily available mobile phones, Android phones and iOS phones that are there and have GPS applications on them. As Rombi, we also have our own application that we can get started. This is almost no effort or no cost a way to get started and get a taste of what it could mean for your business to know ahead of time where your shipments are and how the delays are happening. The next step to that is there are inherent problems with the cell phone based solutions. Like we talked about, the phone may not work, it may get in an area where coverage is not there, or the battery may go out. To avoid any kind of human interventions, the next level would be to try out with our devices, which is again a very simple, pure OpEx model. There is no upfront cost. You pay for what you use. Can get up and running. The entire solution is extremely portable, and you can get up and running essentially as simple as ordering a device, putting it in your truck, and that's it. Basically, the whole system is pretty much plug and play. You will start receiving stats directly from our portal and from our platform. Service-driven model. Once the proof of concept is done, we can help out in sort of identifying the areas which are important. The study that we do will be very specific and very tailored to business or the specific processes that you have, and how you can benefit from our solution. How do we maximize the potential of our devices? So then we will look at essentially expanding it from there. But first step is definitely always to get started.
Thank you, Sailesh. So I think we have come to the end of your presentation, looks like. So for the audience benefit, Rombi is an IoT company. We are an on-demand solution for monitoring your goods and assets across your enterprise. We do it indoors, we do it outdoors in yards and warehouses, and we also do it in field, which is also outdoors, as well as in transit, of course, which is where the ETA picture comes into play. We are present in more than 7 countries, and we have more than 200 enterprise customers today using our solution in its various flavors across pharma, FMCG, in food and beverage, in the agribusiness, in retail, and so on. And very interestingly, in the last 1 year, a lot of big solution companies have been partnering with us to take this solution to the market because their customers are still lacking the power of real-time data to do all of these predictions in real time and be efficient. So we have companies like T-Systems, Syntel, Accenture, TELUS, Bell Integrators. So if you are a manufacturing firm who is shipping something, buying something, this could be of a lot of value to you to try, like Sailesh said, with almost zero infrastructure. If you're a solution partner working with manufacturing companies in the warehouse or for logistics, this could be something that you could add in terms of value to your existing solution for your clients. So as we come to the end of the webinar, we will basically open the floor for questions, if any. You can ask your questions in the Q&A button, which is there on the screen, and I'm more than glad to share that with Sailesh for a quick response. Any questions? Okay, we have actually we have a few. Let me try. Let me try to phrase this as crisp as possible, Shailesh. We have a question on whether we can feed the system a database of collected data, and what would happen. Would we be able to make sense of it?
Sorry, could you repeat, Prem?
Sure. So the first question is, can we feed the Rombi ETA system with a database of previously collected data?
Um,
So
this,
I think the reference here is to the fact that there is already some data collected through GPS systems in the past. So can we use that data to basically make our system smart, the machine learning that you talked about, and enable the customer to come out with a prediction on when future shipments would arrive?
right. So technologically, it is possible. We have done it for some of our large customers. The only part to remember here is that it becomes very specific. When we develop these models, they become very specific to that particular use case, and it may have different set of features. I think the short answer is that yes, it is possible. The long answer, I think, will depend on what business it is and how do we how does that it really impact the ETA. If there are other considerations, will take time to build it out. But our processes are flexible enough to be able to ingest the data and create specific models by account, and also being able to ingest data from other systems.
Okay, thanks, Shailesh. The second question we have is, firstly, there's a compliment for you from this audience. They say, found it very interesting. About the machine learning part, which you talked about. I want to know whether it's deep learning or which kind of model is the machine learning using. I feel like very recurrent routes could be predicted with weighted network graph. Is that true?
Yeah, so you could apply simple mechanisms to the repeated routes. Our solution is slightly different, and we actually tried out with many different algorithms. The one that we found working best for us is decision trees that we are using. We have tried with the random forest and AdaBoost and other kinds of decision trees. Ultimately, we ended up with a combination of these. We are using an ensemble to predict this. But you're right that as repeatable the problem becomes, it becomes easier. And that's where I think the analysis comes into picture, where we have to create every kind of specificity as a different feature that we feed into our data models. And we have to try out certain routes. Some models will fare well than the other ones, right? So as the use cases become more and more disparate, it requires different kinds of considerations to be implemented. So it's not going to be one size fits all. And that's why we have a team of data scientists who constantly look at this, analyze it, and come up with the recommendations and keep making it better over time.
Thanks, Shailesh. We have a question from one of our YouTube viewers. We have a lot of people watching this on our YouTube channel as well. So the question is, you talked about our ETA getting better with time, and they want to understand a little. This gentleman wants to understand a little more about this, how it gets better with time, and what is it that happens in the system which enables it to do so in an automated manner.
Perfect. Very good question. So where data helps us is to identify the trends and set aside the exceptions from the norms, right? So the more data we have, we can establish this very easily. So give you an example. Let's say we have two shipments. If one shipment is delayed because the vehicle broke down and the other one did not delay, we cannot tell by looking at these two shipments, or at least machine cannot tell, that is vehicle breaking down is normal, or is it a specific condition that happened for that shipment. Now, if you extrapolate the same data, or if you have more data, let's say we go to 10 shipments, and of these, 2 actually have delayed because the vehicle broke down, and 8 are not. System then knows that this is not a norm; it's an exception. So that's a very simplified example, but there are many such conditions that come across where having the large amounts of data will help us, or help system determine these kinds of things better. This all analysis happens automatically when we train the models. This goes into the training, and we experiment with various different kinds of training data sets, and keep making it, keep changing this training set, because things change. So let's say last year, if you take a data for year before, the highway road was bad, right? This year, things got better, and then the road got fixed, and now the traffic speeds are different, or it's much better, smoother traffic we are seeing. So we have to keep improving our models to take such subtle factors into account, and that's where I think a lot of the effort goes in to make sure that our models stay on top of all these conditions, which are not reported anywhere, which are not really published anywhere.
Thank you, Sailesh. We will have we have a couple more questions. We are 2 minutes on the dot. So one is does the solution work in Somalia when it comes to network? Because calculating ETA in some parts of the world is, or not even calculating ETA, but getting data in some parts of the world is still difficult, right?
It is difficult. In fact, we'll have to see basically what else works in Somalia that we can do ETAs with. So it'll be a tough question, basically, given the infrastructure condition of that country. But will be an interesting challenge to look upon. There is no short or easy answer to that question. I think it will be when the rubber meets the road, we'll have to see what kind of data we can tap into.
Okay, and the last question that we are taking for the session is about the long trips. You said that it's more than 4 to 6 hours, usual times when stops occur in between load and unload. But sometimes this occurs in less time than that, because it's not possible to know when the truck started to work. Do you always track trucks, or when do you start to track a truck in order to avoid having a stop for the shorter trip? I hope I'm communicating this question right. But I think the question is around the fact that you usually said that it takes 4 to 6 hours for the truck loads and unloads to happen. What happens when it is lesser than that in short trips is the question, if I understood this right.
Right. So the 4 to 6 hour yardstick was more towards what we call as long-term or long distance travel versus short travel. For the algorithm to work, it doesn't really matter, basically. So when we train, the models can take as short as a 4-hour shipment or even lesser shipment, and we can provide predictions in that. So it does not have any implication on the shorter journeys, or the duration of the journey does not have any implication on the accuracy of the ETA. But the thing is that as we get closer towards the journey being finished or end of the journey, in many cases, your basic ETA predictions are okay. It is the long-term journeys that we have seen the problems. Now, there could be certain exceptions to this rule where if you are making too many stops in between, and that could be a complete legit use case where you have to stop for, let's say, partial offloading or partial onloading in the middle, and you have many such stops, your basic ETA will not work. And in that case, our ETA will actually fare well.
Wonderful, Shailesh. Thank you. Thank you so much for the detailed answer. We are on the dot, and to respect the time of our audience, I think we should come to a close. If anyone has more questions, so we are more than glad to answer. It's just that we got to take that offline. So I would request you to mail us your questions to sales@rombi.com. Let me repeat, sales@rombi.com, and we will route them directly to Sailesh to answer them and get in touch with you. And of course, if you would like to taste this flavor of the Rombi ETA, you can very easily sign up for a free demo at the end of the webinar. So you will have a link, and upon clicking the link and submitting your details, we will reach out to you and provide you with a free demo of this ETA innovation that Shailesh and his team have worked very hard on over the last few years. Thank you, everybody. Once again, respect the time you took off to attend this. Thank you, Sailesh, and thank you to everybody in the audience. Good day.